Welcome guys, let's find out the technical rate of substitution, elasticity of substitution, and elasticity of scale for a CES production function when the coefficient for the labor and capital are not equal and also they are not equal to 1. So let's start with finding the technical rate of substitution. For the technical rate of substitution, we have this simple formula. TRS equal to negative or minus marginal product of labor divided by marginal product of capital, and is equal to minus the marginal product of labor is equal to the partial derivative of production function or y with respect to L or labor, and marginal product of capital is equal to the partial derivative of this y with respect to capital. So let's find out. Now we have the negative sign here. So the partial derivative of this function, which is a kind of power function, as first we need to take the derivative of this power function first, which is equal to 1 over rho multiplied by AL to the power of rho plus BK to the power of rho whole to the power of 1 divided by rho minus 1 multiplied. Then now we need to take the partial derivative of this inside function with respect to L, which is equal to A multiplied by rho multiplied by L to the power of rho minus 1. In the here, derivative of y with respect to k, again, we need to take the power function derivative and also the inside derivative. 1 over rho multiplied by AL to the power of rho plus BK to the power of rho whole to the power of 1 over rho minus 1 multiplied by B. Now we need to take the partial derivative of this function with respect to capital now. B multiplied by rho multiplied by K to the power of rho minus 1. Rho minus 1. So there are some common factors that we can cancel out. 1 over rho with 1 over rho will cancel out. This rho with this rho will cancel out. This term with this term will cancel out. So we will have negative AL to the power of rho minus 1 BK to the power of rho minus 1. Also, we can write down the technical rate of substitution is equal to minus A over B multiplied by K divided by L to the power of 1 minus rho. This is the final result for the technical rate of substitution in case of this CES type production function when A is not equal to B and not equal to 1. And in the last video, we worked when A is equal to B is equal to 1. So now suppose also when A is equal to 1, B is equal to 1, we will have exactly the same result that we found out when A and B are equal and equal to 1. So now let's move out to the next step to find out the elasticity of substitution. For the elasticity of substitution, we have this formula. Elasticity of substitution is equal to derivative of ln of K over L with respect to derivative of ln of absolute value of technical rate of substitution. This is the formula. So now we have technical rate of substitution is equal to minus A divided by B multiplied by K over L to the power of 1 minus rho. So we need to transform this function to logarithmic form in order to take the derivative of ln of K over L with respect to ln of TRS. So what will we do that? We have this one. The technical rate of substitution is equal to, let me write down again, A divided by B multiplied by K over L multiplied by to the power of 1 minus rho, to the power of 1 minus rho. We need to find out k over L because this term here, k over L. So we need to move out everything else to the other side of the function. So what we need to do, the first one, we need to multiply both sides by b over a to change this one here. And also we need to raise to the power of 1 over 1 minus rho. 1 over 1 minus rho. So then this term b over a with a over b will cancel out here, and also this term will cancel out with here. So in this side we will have b over a multiplied by technical rate of substitution to the power of 1 divided by 1 minus rho. And also we need to move out this negative sign here as well. So this negative sign move here, so we will have another negative sign. But as we just think about the absolute value of the technical rate of substitution, so we can just clean this part and write down the absolute value of technical rate of substitution. Here also we can write down the absolute value of technical rate of substitution. And in this side, we will remain only with k over L. We will only remain with k over L. So now, we need to transform this one to logarithmic form. We need to transfer this one to logarithmic form. So we can write down this one, ln of b over a. This is a multiplication, so it will change to like summation of ln. Ln of TRS, or 1 divided by 1 minus rho multiplied by ln of technical rate of substitution, and equal to ln of k over L. Ln of k over L. Now, in order to find out the elasticity of substitution, we need to take the derivative of ln of k over L with respect to ln of TRS. So the derivative of ln of k over L with respect to derivative of ln of the absolute value of technical rate of substitution is equal to, this term does not have any ln of TRS. So the derivative of this one, because it's a like constant number, it will become equal to 0. And the derivative of this term will remain with this one, this part. The derivative of this part will be equal to 1 divided by 1 minus rho. 1 divided by 1 minus rho. So this is what? This is the elasticity of substitution. Elasticity of substitution. So the elasticity of substitution for the CES production function where A is not equal to B is not equal to 1 exactly is the same as we found out when A is equal to B and is equal to 1. Elasticity of substitution in both cases is equal to 1 divided by 1 minus rho. And it's a constant number. So elasticity of substitution for the case of CES production function is some constant number, because rho is a constant. Rho is just a constant number. So you just need to divide 1 by 1 minus rho. This is the elasticity of substitution. This is the elasticity of substitution for this CES production function. Before moving to the next part to find out the elasticity of a scale, here I want to request you guys to please subscribe my YouTube channel, like the videos, and also share your comment. When you subscribe my YouTube channel, the YouTube algorithm will introduce my videos to other colleagues as well. If you like, so it means my videos satisfied your expectation. And also again, the YouTube algorithm will introduce my videos to other students. They need the similar lessons as you need it. So now, let's move on to the next stage to find out the elasticity of a scale for this typical CES production function when A is not equal to B and not equal to 1. If we change all input by some kind of a scalar like t, then output after scaling will become equal to t multiplied by the initial output function or production function. And from the previous videos, we have that elasticity of scale is equal to the derivative of output after scaling with respect to scalar multiplied by scalar divided by the output after scaling. So this is the formula. So now by using this formula, we will find out the elasticity of scale for this CES production function. Let's do that. So then Ex is equal to the derivative of y of t with respect to t, derivative of this one. So we have just only t here. Then if we want to take the derivative of this one, we will remain with this part. Is equal to a multiplied by L to the power of rho plus bk to the power of rho all to the power of 1 over rho multiplied by t, that t, divided by y of t. Y of t is equal to this, the whole term. Then we have t multiplied by al to the power of rho plus bk to the power of rho whole to the power of 1 over rho. Now we can make it simple, this term. We can cancel out some similar terms. We can cancel out t with this t. We can cancel out this term with this term. And finally, we will remain with the value of equal to 1. With the value of equal to 1. So now, we got that elasticity of scale and the CES production function is equal to 1. So finally, Ex become equal to 1. And from the video that we were talking about the elasticity of scale on general and formula introduction, we come to the conclusion when the elasticity of scale is equal to 1, we have what kind of production function? We have constant return to scale production function. And if the value of elasticity of scale is greater than 1, then we have increasing return to scale production function. And when the value of Ex or elasticity of scale is less than 1, then we have decreasing return to scale. But in this case, as we have Ex is equal to 1, then we will have constant return to scale production function. If you remember the last video, then we were finding the elasticity of scale for the case of CES production function when A was equal to B and equal to 1. So here we can know that in both cases, either we have this condition or we have this condition, A equal to B equal to 1. We have exactly the similar result. Elasticity of scale is equal to 1, and thus CES production function exhibit a constant returns to scale. So therefore, in any case, when we have this form of CES production function, then we have constant returns to scale. So this is the final conclusion. Hope you enjoyed this video. Thank you so much for watching. See you next time.